We want to estimate the loss of polarization of a hyperpolarized solution during transport from the hyperpolarizing equipment to the MRI scanner as it traverses through different magnetic fields. Our technique estimates the spin-lattice relaxation time of hyperpolarized solutions at low magnetic fields with high accuracy.
This method is not limited to dynamic nuclear polarization and can be used to estimate the spin-lattice relaxation time of other methods of polarization, including para-hydrogen-induced polarization.
When performing this technique, make sure that the hyperpolarized sample doesn't cross or stay at a zero field region for any period of time. Otherwise, you may completely lose the polarization.
Prepare 1 milliliter of stock carbon-13 enriched pyruvic acid solution, widely used for in vivo research, consisting of 15 millimoles per liter of triaryl methyl radical dissolved in 113C pyruvic acid. On the dynamic nuclear polarizer software interface, click on the Cool Down button to lower the temperature of the variable temperature insert to 1.4 Kelvin. Once the DNP has reached the desired temperature, load 10 microliters of the stock solution in a sample cup. Open the turret doors, and insert the cup into the VTI using an insertion wand specifically designed for this task. Quickly extract the wand, and make sure the cup is released. Then, close the turret doors and allow the temperature of the VTI to return to 1.4 Kelvin. Meanwhile, prepare the DNP to run a microwave sweep in order to find the optimal radio frequency for the hyperpolarization of the stock solution. At the end of